Everyone, this is Mr. 13 Things coming at you with probably less than 13 things here as we look at how you can go about manipulating and using the open source Khan Academy framework to do something called topology. And you'll see what that means. Topology is the study, mathematical study of adjacency and inclusency, or something like that. So basically, if something is inside of or on top of or left or right of something else. And that where that's used to great effect is if you've got something that you can tie to a place on a picture, and that, as far as I can tell, is a great way to jury-rig things like multiple choice tests, even just by dragging the dot to the right spot. So we'll see what that means here in a second. And what I'm going to do is just going to go through pretty quickly here. This is a relatively advanced and not completely shook out manifestation of the Khan Academy exercise framework with really no point to the exam, but it's going to kind of expose you to some of the things that are on the exercise framework. So you see right here, this is inside the regular Khan Academy wrapper. If you are doing it off of your own site, it will not be Khan Academy. This actually is running locally. You see the local host here. So I am running a Python server, basically a Python. So I'm serving off of my own machine, and I'm running something that basically I downloaded from Khan Academy and then wrote or adjusted the code, and we'll see the code here in a second. So so the stuff outside here is the wrapper, and basically the exercise, I'm going to scroll through it, area is the kind of off-white here. It has basically the solution area here, the answer area, hint box, and you'll see later these are separate CSS or cascading style sheet definitions, and so you can hide and do different things with those. This is the type of thing that out on the Khan site they're adding a lot more functionality to by adding hot boxes and things like that, but that over time may drift to the kind of the homegrown or the installations of people using the framework, but for the moment you'll see a little bit less functionality here than if you were in fact out at Khan Academy. So what I've got laid out here, and you'll see later on, is I have a coordinate plane basically that begins with a dot in the center, and it's going to be defined as going from I think 1111 to minus 1111. And you'll have to basically understand a little bit about coordinate systems or play around with it. So it's a good use for figuring out where you are on a plane. This is again a 2D coordinate system. And what we're going to use it for, I would guess, mostly is for identifying things that can be explained in pictures, exams like that, or quizzes like that. Actually doing some tutoring that way. So move the dot to different places, and if the student doesn't know, the learner doesn't know, it can be moved for them. And also purely for simple multiple choice tests when there is one answer. Learning to just kind of manipulate one form pretty well so that you can very quickly come up with some ideas to use this functionality. And the functionality is developed by the people at Khan Academy, particularly I think Ben Eater. Anytime you see something that's really slick, there's a good chance that Ben Eater did it if it was very intuitive, along with a lot of other great people, but Ben Eater being the volunteer turned professional at Khan Academy. He was a professional before he was a volunteer as well. So what you've got here then, and basically I've just got a picture brought in. We're going to see how that comes in. I have some circles brought in. And if you notice here, that's one of the things that starts to kind of cause problems over time as this answer box gets bigger or smaller as they develop. So you might want to avoid using this top right area and just keep your kind of pictures and solutions over to the left. So that's what it looks like. You've got a dot here, and what I'm going to do is I'm going to move this dot around, and you can watch right up here. Right now that dot is reporting something back. Right there you see how it goes from true to false. That is reporting whether it is inside or outside of a defined shape that we'll see here in a second. So I'll go through the hints real quick. Hint, 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 and right there you see the defined shape that we'll see defined in a little bit in terms of in terms of what the data looks like. And that defined shape is obviously in the negative y, both in the positive and negative x. And you see as this thing goes inside of it, it turns to true. This side of it turns to false. And that's in fact why one would hide this from the student, but not when you're developing, so you can see whether the things in fact are correct. You're going to see this is in fact understanding of how things work on a coordinate plane is why you'll learn to get around in either GIMP or Smooth Draw 3.0 or some other graphic design program, so you can work in this kind of coordinate plane. And that coordinate plane could be pointing you to words, could be pointing you to moving pictures, it could be pointing you to any number of things. Alright, so that's that, and as I move around here, I also have some larger text that's very readable that comes in and we'll see later as a label. So that's what it looks like to the user. So the answer would be, the question would be something like move the dot to the teacher's chair, or move the dot inside some particular shape. Alright, that said, we can now bring this up and I'll show you what in fact the code starts to look like. And once again, great apologies to the people at Khan Academy. The code is not the best code, but it is code. And so I'll go down from the beginning here. This basically is, as you develop more and more, you will not want to put all of your JavaScript in the actual exercise, but in terms of keeping it compact as you're just developing, it's not a bad idea, I would guess, to keep a lot of your code actually inside of the HTML file for the exercise you're developing. So we'll talk later about abstraction and functions, but basically as you go down through here, there are a bunch of functions defined, function, 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 and then eventually you get to the body, and this would be what the most simple exercises you would have seen. You define the exercise, you define the variables, and here you start to see those points that we're defining that shape. At least one of them, I got three different shapes kind of defined here. So points, points 2, points 3. So these are variables defined with different names. And we're going to go now through then to look at where the definition, the coordinate plane. And you're going to see this is something to more or less get 2 or 3 baselines, 2 or 3 very simple exercise templates, if you would, and then switch in and out different pictures and different definitions. This code eventually is not bad to understand, and the place to do that is out at the GitHub site, where they have a lot of this managed in a wiki. So you see here, basically the big definition is right here, where you're defining a graphy. They call it a graphy, more or less a graph, and that graph is going from minus 11, 11 to minus 11, 11, and one is the x and one is the y. I do not think that these are points, which is what's kind of odd. You notice there that the label went in at minus 5, minus 5. That was what you saw. You notice here that the picture, and if I go back in a second, you see there's that little tiny picture. It called a function. This is the name of the picture it was going for. This tells it of a location of the picture. And this does a little bit of a shift. And this does the x number of pixels and the y number of pixels. And what's great about this is that it in fact will adjust or scale your picture to fit into these confines. I would really suggest that if you get going doing this, that you know what is the pixelization in terms of the x and the y of your picture. Then the circles are drawn here, and then the rest of this coming down here, we're going to skip through, and that is the functionality. This is the functionality where the point knows where it is. That movable point where it's reporting consistently. You get down to the bottom here, and you get into the hint area where each click does things like draw the picture as you go through. So as you go through here, the big thing that once you got it all sussed through, that you would eventually do is you would change a little bit of the code so that something was hidden so the user or the student could not see actually what the answer was. So let's once again look at that with all that in mind and then make a couple changes here so you can see how you go about learning here. So I've got this opened up in Notepad. I'm local server. I'm going to go ahead and redo that. Great to have a big screen to do this if you can. So you see how everything comes in there, and then the way you start sometimes learning to find your way around is just to go in and change one thing. And so don't change two things, change one thing. So I'm going to go ahead and change this kind of shift number here. Right, and usually you don't want to start with shifting to 0, file, and I'm going to save that. I hit a file save, and then I just hit a reload, and you'll see now where that shifted, which was a pretty good, nice way to define that, is, you know, right at the top left corner. And I'll leave it there and let you know that by default, a lot of graphic design in web design and in HTML, where people are taking advantage of pictures, even in terms of your Google Earth and all the GPS and GIS stuff, this locational knowledge is hung off the top left corner. It's something called a left-hand coordinate system. And so what that means is you put your pick up your left hand, you point your finger down positive X, your thumb goes in the Z, or the kind of up in real space direction, and where your crocked, I don't know, expressive finger goes is Y. So it's a little bit different than what you're used to if you've just been doing standard Cartesian coordinate math like we do from day one. This is not unusual, however. A lot of survey work has done something like this with the left-hand coordinate system. So that said, you start kind of playing around. You go back and forth until you figure out how you manipulate pictures. And once you kind of get it all worked, it's not bad. So I'm going to change one more thing. I'm going to put that as a 400. I'm hitting File, Save. I'm going right back through. I'm going back there. And I am, in fact, then looking down through. And there you see it moved it off to the right. And this then will show you more or less, if you think that this is going to the area here somewhere around 11 or 10, then this basically was, let's look at it, the scale, which is assumed it's 400, right? And I think it was in the order of 10, so like 1 to 40. 40 pixels equals one unit. Now, that's something that you'll want to really get established and understand as you might deal with different pictures, but it becomes relatively quick here, and we'll work that in the next video, to kind of set up this set of questions that maybe you scribble off on your Wacom tablet or on your iPad or whatever else, with the little check boxes or general areas, and students can kind of and do the multiple choice there. Again, the functionality is other better ways to do it potentially within Khan Academy. Much better, especially if you're doing something that's mathematical. But in this case, you're trying to kind of learn to adapt 2 or 3 or 4 or 5 templates to how these particular exercises work as you wait and get students kind of just involved in seeing where this thing's going, and collecting some really good data, because it can report where the student is dropping the dot. So it doesn't just have to be a true or false. It can, in fact, report where the student is dropping the dot. So we'll leave it at that, and we'll see if we can post this out to Mr. 13 Things. Remember, 13 things come from the fact that if you can't count to 12, you count to 13 when you start at a clock and double count the beginning. I'll explain that later. No going back now. 13 things at a time. Thanks for listening.